Hello everybody, welcome to this presentation on a beautiful theorem on number theory. The difference between any number and its reverse is always divisible by 9. Today we will explore why this is true and prove it step by step. The theorem states that the difference between a number and its reverse is divisible by 9. By the reverse, we mean the numbers with the same digit written in opposite order. For example, 123 minus 321 equals to minus 198. 118 and 98 divided by 9 equals to minus 22. Minus 22 is divisible by 9. 452 minus 254 equals to 198. And 198 equal divided by 9 equal to 22. And also 1001 minus 1001 equal to 0. And also 0 divided by 9 is equal to 0. To prove the theorem, let's represent the number. Let the original number have digits. In equals to dk minus 1, dk minus 2, d and d2, d1 and d0. Where dk is the first digit and d0 is the last digit. In expand form, we can write n equals to dk multiplied 10 to k plus dk minus 1 to multiply 10 to k minus 1 plus d1 multiply 10 and plus d0, where each di in 0, 1, 2, and 9, and dk is not 0, because if dk is 0, then the number of digits in n is decreased. The letters of n also is represented as r. R equals to d0 to d1, d2, and dk minus 1 and d3. In expand form, we can write r equals to d0 multiplied 10 to k plus d1 multiplied 10 to k minus 1 plus dk minus 1 multiplied 10 and plus dk. Notice how digits are reversed in power of 10. Here we can see the position of digit in the number and of the reversed number. The difference we want to know compute the n minus r, and the original digit and r is the reverse digit. N minus r equals to sum of I from 0 to k, di 10 to I minus I from 0 to k, di multiply 10 to k minus r. N minus r equals to I from 0 to k, di multiply 10 to I minus 10 to k minus r. But in second sum, the digit di is multiplied by 10 to k minus r. So we can write n minus r equals to sum of di multiplied 10 to I minus 10 to the k minus I from 0 to k. The key observation, we know that the 10 congruent to 1 module line. Therefore, for adding a negative integer m, 10 to the m congruent to 1 to the m congruent to 1 module line. So 10 to the I minus 10 to the k minus I congruent to 1 minus 1 congruent to 0 module 9. Thus, we can see that n minus r equal to sum of di minus 10 to the I minus 10 to the k minus I from 0 to t congruent to sum of di multiply 0 I from 0 to k congruent to 0 module 9. This means that n minus r is divisible by 9, or 9 divided s minus r. Also, there are another simple proof using the divisibility rule for 9. A number is divisible by 9 if the sum of its digit is divisible by 9. Let's S to be assumed as sum of digits of n. The sum of digits of r is also s since the digits are the same, just the order has reversed. Therefore, the sum of digits of n congruent to S mod 9, and also the reverse number r, the sum of reverse digit of reverse number r equal to S congruent to S mod 9. N minus r congruent to S minus S congruent to 0 mod 9. This means that also this is much simpler for fun. Show that the 9 divides the N minus r. Also, there are generalization for this theorem. This works in any base. In base, a bit difference between a number and its inverse is divisible by b minus 1. Since b tangent to 1 mod b minus 1, we have b to the m tangent to 1 mod b minus 1. This is the same argument that we formerly use. For base 10 or decimal, divisor is 9. For example, 123 minus 321 is equal to minus 198. And then we can see that 9 divides 189. In base 2 or binary, the divisor is 1. Here we can see 1 or 1 in base 2 minus 1. Or 1 base 2 is equal to 0, and 0 also divides 1. Or in base hexadecimal 16, the divisor is 15. 1a in base 16 minus a1 in base 16 equals to minus 87 in base 10, and then we can see that 15 divides 135. Although here we can see the more examples. Two-digit number here we can see for number 21 reverse 12 difference 9 delivers by 9, or for 78 the reverse is 87, difference is minus 9, all the divisible by 9. For three-digit number also we can see some example. For example, the last row is 789, the reverse is 987, difference is minus 198, this is divisible by 9. Any other you can do summary of the theorem, the difference between a number and its figures is divisible by 9. This is a different step that we have presented it. And final result for any number, and 9 divides n minus reverse of m. Thanks for watching. See you in next video.